Hi guys, my name's Jamin, and we're going to be talking about series in this video, specifically financial math questions, annuities and loan repayments, that sort of stuff. So, sequences and series is a pretty interesting topic in 2U because it has a huge range in difficulty. You've got those multiple choice questions at the start where you're just finding unknown terms and stuff like that. They're easy. Then you've got some stuff in the middle that might be an infinite series or perhaps something a little bit more complicated with a geometric series, something like that. They're okay. And then you've got the questions we're going to talk about today, the financial math ones, loan repayments, annuities, interest, all that sort of stuff. These can be really, really tough. And while it might seem like this is a fairly small topic, these form a decent chunk of your marks. Over 10% of the marks in the last 4 years have come from this topic. And this specific question type of financial questions, they are usually a 5 mark pluser. They were 5 marks in last year's HSC. The question we're going to be looking at is a 7 marker from the year before. So a lot of marks on offer, fairly tough question type, really important for you guys to know what's going on. Before we start, just a quick review of the stuff you need to know from this topic in general. So we're not going to be using these results so much. These are the arithmetic series results at the top here. So they're for arithmetic series, where you get the next term by adding a common difference to your previous term. We're not going to be using those so much. We're more concerned about these ones, the geometric versions. And this is because we can use these to model the application of interest with an interest rate of R. So remember, for a geometric series, we get the next term by multiplying it by a common ratio. That's this term here, that's the R. The first term is A, just like it is for an arithmetic, and N is just whatever term we're looking at, the nth term, or in the case of sum, we're taking the sum of n terms. We have this infinite sum formula down here as well, A on 1 minus R. We don't use that in this topic either, but it does come up a lot, so make sure you know that it exists. The sorts of things you should be able to do, particularly with geometric series, is find sums and find missing terms, and potentially find ratios and differences. That stuff I'm not going to talk about in this video, but do make sure you brush up on it. If you have any questions about that earlier stuff, jump onto the ATAR Notes 2-unit math forums. I'm there to help all the time, answering lots of questions. If you have any stuff to ask that I don't cover in this video, make sure you go on there and ask it, and I'll be happy to lend a hand. So the question we're looking at today is from the 2015 HSC. It's a 7-mark question, probably the most marks that's been assigned to one of this type of question for a while, which is why I've picked it to look at. So we have a situation where Sam borrows $100,000 to be repaid at a reducible interest rate of 0.6% per month. We're letting AN be the amount owing after n months, and M is the monthly repayment. We don't know that just yet. So the first sort of question part of most of these sorts of problems is always to show a preliminary result, that is in this case to show A2 is equal to this expression, and then to generalize that to an expression for AN. These are almost always the first two parts of a question of this type, and it's really important that you know where these results come from. A lot of people like to just use formulas for this sort of stuff. It doesn't work because NISA wants to see you do the working. So we'll have a look at that. And then we're asked to do a few things. We're asked to find an amount owing after 120 months, and then we're asked to use that to find how long it's got to go from there. So let's get into it by attacking the first question first. So we're asked to show that A2 is 100,000 1.006 squared minus m lots of 1 plus 1.006. Now, to do this, the first step is to look at our problem and to make sure that everything is in the same time period. So in this case, we want months because we're looking at a monthly repayment. In our case, the interest rate is also given per month. It's 0.6% per month. So in this case, we don't have to make any adjustments. We'll let the interest rate be 0.006. And what we're going to be multiplying by is 1 plus this amount. The reason we do this is because when we add interest on top of a quantity, we don't want to get rid of the initial quantity. So expressing the number this way lets us keep the initial amount That's what this 1 does. And then add the interest. That's what the 0.006 part does. Yeah, so multiplying by this number adds the interest in that way. So let's step through. We know that we start, A0 I'll call it, the initial amount is 100,000, right? Our job from there is to step through what happens to this amount to try and get this expression at the top. It's only worth a mark, so it shouldn't take more than a few lines. After the first month, what we do is we have this initial amount, A0, we apply an interest to it, so that's multiplying by 1.006, and then we subtract the monthly repayment, whatever that happens to be. So that's A1. A2, the exact same thing happens, but we don't start with 100,000. We start with that A1 amount. But we do the same thing. We apply the interest and subtract a repayment. From here, let's take this expression for A1 and pop it into this part of the expression here. When we do that, we're essentially multiplying everything in A1 by 1.006. That gives us 100,000, 1.006 squared, minus m lots of 1.006. And then we still have this extra minus m at the end. To get the result they've got, all we do is pull an m out of these latter two terms. So we get 100,000, 1.006 squared, minus m lots of 1 plus 1.006. Just a quick point to notice that we don't have a subtraction in the middle here. The subtraction was handled by pulling the subtraction at the front in the factorization. So these two subtractions in the previous line both end up at the front like that. So we've proved the result. This is always what we do. We take the amount that we start with and we just think logically, okay, we're applying an interest rate, we're subtracting a payment. Once we figured out that pattern, we just repeat it recursively, always using the previous line as our starting amount for that month. This will slowly let you build up the expression that they need. Before we generalize to AN, let's just do one more. Let's do A3 specifically. So when we do that, again, the pattern is the same. We start with A2, we apply the interest rate, and we subtract a repayment. Expanding that out, what we get is 100,000, 1.006 cubed now, minus m, lots of, and what we get is a third term in here. Now it's 1.006 squared. So this should start to make the pattern a little bit more obvious. We should now be able to generalize to AN. The pattern is pretty easy and it's in two parts. The first term is always just going to be 100,000 times 1.006 to a power. Then we're subtracting m, and it's just a series that starts at 1, going up with a common ratio of 1.006 until we get to another power. To figure out what all those powers are, all we do is link the numbers that we need to the subscript that appears for the a value that we want. So for the first term, for example, 100,000 times 1.006, notice that in A3, the power is the same as the subscript. So this will be just like that. Our subscript is n, so this also needs to be an n. And look, if you weren't sure, that's also what they have in the question. So it's a pretty safe bet. From there, we'll write this out, this series, and the question is, where does it stop? Again, we look at the line above and we see that this number here is 1 less than this subscript here. So 2 is 1 less than 3. So what that means is that we stop not at n, but at 1.006 to the n minus 1. So we're almost there. The first part of the expression is set. We just need to work with this series here. Now what we notice is that this is a geometric progression. Its first term is 1, and its common ratio is 1.006. we can use that information to pop that series, and instead of writing it as a series, just write it as the sum of a series using the sum formula. So, recall from your reference sheet, the formula is A, which in our case is 1, r to the n minus 1, so 1.006 to the n. Now, in this case, n isn't the same n that we have in the question. N just represents how many terms are in the series. If we count how many terms are in the series, we have to be careful. We have 1, 2, n minus 1 powers of 1.006, but we also have this additional 1 as the first term. So the amount of terms in that series is actually n. n minus 1 powers of 1.006 plus this constant 1 out the front. So there's n terms in this series, so it goes to the power of n in our formula. And on the bottom, we have r minus 1, which is 0.006. So that's the question. Now again, the most common thing that people stuff up is where this power goes. So particularly, a lot of people would incorrectly write n minus 1 here, because that's the highest power in the series. Really important to remember, n in this series formula is just how many terms are in the series, and you have to be really careful when you count, because they may not give you an example expression, so you need to know how to adjust it. Now this next part of the question is actually really easy, and we expect that because it's only worth a mark. We're told that Sam makes monthly repayments of $780. We've been told the value of our M. We're also told that we want it to be shown that after making 120 monthly repayments, that the amount owing is $68,500 to the nearest 100. So essentially what we're doing here is we're just letting n equal 120, and we're asked to check that it matches 68,500. This is just a calculator question. So this is the easier of what can come next in a question like this. When you don't have to do any rearranging, it's purely a calculator question. So all we're doing is A120, and we pop those numbers in blue into this expression and pop it in the calculator. If you do that, what you'll get is $68,499.46. Really important to show the value pre-rounding, because otherwise they're not going to believe you did anything. So to the nearest 100, that is definitely 68,500. So a really easy question. Again, it's the easier of the two sort of pathways they can go. The next question is going to go the tougher way. So now what we're told is that Sam is, after making that 1/20th repayment, going to make another payment, and it's going to reduce the amount owing to $48,500, and everything else is unchanged. After how many more months will the amount owing be completely repaid? Now, this is an interesting sort of ask of a student, because it's not something they do often, but all we have to do here is, if you think about it, we now have a new amount owing of $48,500, and we're asked to find how many more months until the amount is repaid. Essentially, this is a repeat of the initial scenario, except instead of starting with 100,000, we're now going to be starting with 48,500. So now we redefine AN as this new formula, and it's exactly the same, except the starting amount isn't 100,000. It's now 48,500. Besides that, the expression is identical. And again, this is because we're now looking at a new sort of, we've reset the counter essentially. We've said, okay, after this 120 repayments, we want how many more months, and this is now how much I have to pay. So we've sort of restarted the clock. You'll get a mark just for being able to redefine the series in that way. From here, we want to know how many more months until the amount owing is completely repaid. That is, we want AN to be equal to 0. And this is the tougher question, because now we're going to have to do some rearranging. We want to find n. So, for a to the n to be equal to 0, we just substitute that in, What I'm also going to do is tidy up this second expression here, because that m value we know, that is 780. What that means is that I combine that with this 0.006 on the bottom and just get a straight constant. If I put that into the calculator, I get 130,000. So again, that number's just come from going 780 divided by 0.006. And so instead of having this messy fraction, I just have 1.006 to the n minus 1. From here, let's expand that ladder bracket. So we just have this term at the front unaffected. We have minus 130,000 lots of 1.006 to the n. And then we have plus 130,000. Be careful of the sign change by the double negative there. Rearrange this equation, and we'll pop negative 130,000 on this side by subtracting that 130k. And then on the right-hand side, we have 48,500 lots of 1.006 to the n minus 130,000 lots of it. And what that gives us is minus 81,500 lots of 1.006 to the n. From there, we do some division, and we get 1.006 to the n equals 130,000 over 81,500. The negatives have cancelled. And that simplifies to 260 on 163. So that's our equation. 1.006 to the n equals 260 on 163. To isolate the n, we're now going to have to use a logarithm. There's two sort of ways to approach it. Probably the easier way is to take the natural logarithm of both sides. What that gives you is ln 1.006 to the n equals ln of 260 on 163. Now remember, from our log laws, we can pull this power of n out the front, right? So what that means is that we can then divide, and we get n equals the log of 260 on 163 on the log of 1.006. Note that you could also get here by using the change of base formula. It's really up to you. But if you pop that into your calculator, what you'll get is 78.05 ... Now at this point, a lot of students would round down to 78 and give that as their final answer. That's not correct, because keep in mind, we need the amount to be completely repaid. What this number says is that it's repaid just after the 78th monthly repayment. But we have to make the next full repayment to pay it off, right? We can't just repay the 78th time and then magically in between that and the 79th have it repaid. We need to get to the next one. So that means we have to round up anyway. And so our answer is 79. 79 months until the amount is completely repaid. This round up thing does give students a little bit of grief, and in fact the sample or the marking guidelines for this question, you would have been marked correct even without rounding at all. But technically it's most correct to say that we would need to make that 79th repayment to go that final little piece of the distance to getting the amount fully repaid. So that question is very typical, and it covers most of the things that you could be thrown in a question of that type. A few last minute tips: be really clear in how you derive your financial math expressions that they give you, or maybe that they don't give you. Make sure you're clear in how you derive it, because if you derive it with a small mistake, they can still give you merit as long as the approach is logical and otherwise correct, right? So you need to be careful that you're not completely blowing it, even if you're a little unsure. A few common errors: check for those off by 1 errors with the powers. So again, make sure that you understand the difference between the n in the series formula and the n in your question, if there is one. Usually there is. Check that your interest rate is converted correctly. Remember, if you have an PA interest rate, a per annum, to get it to per month, you just divide it by 12. So if you want to go from per annum to per month, divide by 12. Or it may even go the other way. Just be careful that everything is in the same sort of unit, months or years. More generally, beyond just financial math questions, if you're going to use the infinite series formula rather, make sure you justify it. Remember, you can only use this formula if the common ratio has an absolute value that's less than 1. If it's not, then you can't use the formula. So if you're going to use it, make sure you explain why you're allowed to. And it sounds silly, but make sure you're using the geometric series formula for geometric series. I've seen a fair few papers, actually, where students are using the arithmetic formulae in financial math questions. Financial math is always geometric, so make sure you're using the correct formula. It would suck to understand a question perfectly, but just mess up in the pressure and use the arithmetic formula. Be careful, don't do that. It would really ruin your night if you knew that you just made that sort of silly mistake. So that's it for this video. That question will gear you up for any financial math question they ask. It covers all the main sorts of question types. Again, if you have any questions about math in general, jump onto the ATAR Notes forums. I'm happy to answer any questions, and that goes for extension level courses as well. If you have any questions about study, any courses, anything like that, the forums are there to help you. Also keep in mind that ATAR Notes sells a set of study notes for mathematics. They're $25. You can buy them on our shop. And if you're out for a last minute bit of revision of the content, don't have time to be making notes, all that sort of stuff, these notes might be just what you're looking for. So check those out as well if you're interested. Otherwise, I'll see you guys on the forums. Good luck for your HSC.